Hello fellow enthusiasts, welcome back again to my channel. Let's go into today's video. We're gonna come back at the end to wrap it up. All right, so here I'm gonna show you how to build a walkie-talkie. Last week we talked about the software-defined radio, and you saw the software-defined radio transmitter. And in a previous video, we built a software-defined radio receiver. So in this episode, so here on the screen, you will see the software-defined radio receiver. We built this, I think, last year, and then this year we built the software-defined radio transmitter. Towards the end. In a previous video, I want you to build a software-defined radio receiver. So in this episode, so here on the screen, you will see the software-defined radio receiver. All right, we're gonna stop the echo right now. All right. So on the screen, you've seen the software-defined radio receiver. Now we're going to show you how to build a walkie-talkie. So we start with block diagram as always. The purpose of our using this approach is to eliminate or minimize your dependence on people giving you circuit diagrams, so you can know how to build things from scratch on your own. That has always been the goal. So you know how things work, and you can build it on your own with what you already have. So block diagram again, let's call this a transmitter. And let's call this a receiver. So for your walkie-talkie then, you need a transmitter and a receiver, but most cases you want them in a single unit, and you want to reuse the parts. So you can reuse the RF front end. So your RF amplifier for the receiver for the transmitter becomes your front end for the receiver in the receive mode. And many times you want to reuse the same antenna. And so this is basically what you do. In our case here, we want to use microcontrollers to control our software-defined transmitter and receiver. So, microcontroller for the transmitter, microcontroller for the receiver. Then you have the transmitter module, the TX module, and you also have the RX module. So when you have something like this, you want to unify or commonize a few things, so you can have one microcontroller for both transmitter and receiver, have them in the same unit. So you have the same power supply circuit, power supply unit for both of them, and you can reuse the same antenna. And then you have a switch, toggle switch to go between transmit and receive. So you have one antenna here, and there's a switch that flip between transmit and receive, and one of them will be normally closed. So let's say your receive side should be normally closed, and your transmit side should be normally open. All right, look at that circuit. Now, why do we want to close? Why do we want the receive to be always in normally closed circuit? Because you want to be anticipating signals or communications from outside, and you want only engage the transmit antenna when you actually want to send a signal out, or when you want to call someone. So that's why you want to stay on the receive side all the time, unless you want to be you want to send something out. Again, power supply can be the same for both. So in that case, I'm connecting both boxes, TX and RX, to the same power supply. And then maybe have the power switch as the same. So basically what you need for your walkie-talkie is a transmitter and a receiver in the same unit. You want to commonize as much as possible. In our case, you want to commonize the microcontroller and the antenna. The RF module and the transmitter module are the same, different. They are different, so you have to use different modules for the transmitter and the receiver. And then one more thing you can have in common is the microphone and the speaker. So you want to have microphone to be the same as the speaker. So in our case, you can use the speaker as also your microphone. So the ground will be common, but then one of the terminals will go to transmit and one will go to receive. So you make one of them normally closed, and then one of them normally open, right? Normally closed is when you're receiving, and then for when you want to transmit, then you close it so you can transmit. So this side will be normally open. So transmit is normally open, the receive is normally closed. Likewise, your antenna is the receive is normally closed. So when the signal comes in, it goes through the receiver section and plays through your speaker. And when you want to transmit, you want to flip over the speaker to the transmit portion, and then you transmit, it goes through the transmitter, and then your antenna is also on the transmit side, and then it goes through the airwaves to your receiver, to a receiver. So this is the block diagram, basic block diagram. You can find other things that you can commonize. Here, you can also use the same switch to tune between transmit and receive. But when you write your code for the microcontroller, you can write it in such a way that when you're transmitting on a particular frequency, your receiver is stationary. So um, let me give you an example. Let's say you want to transmit on 70 megahertz, and so this is your transmit frequency. Your receiver is on 70.2. This is your receive frequency, but you want to fix that. Let's just say fixed. You want your receive frequency to be fixed, so people know where to find you all the time. That means for the people in the unit that you're building, like if you're building a system um, for a company or a small organization, for instance, you want to make sure that everyone has a unique receive frequency. So when you transmit on that frequency, only that person will respond to your call, right? And then your transmitter should be able to sweep through all the frequencies except your own, because you don't want to get an echo back. Well, you will have an echo if you use this system we have here, because when you're transmitting, the speaker is actually disengaged from the receiver and the antenna is disengaged, but the system will still be working, receiving the signal, but there's no speaker to output it, so you wouldn't really have a problem. But you can write a code in your microcontroller to so whatever is fixed, you want to skip that. So when you tune it, you say if frequency is equal to, so let's say you have you program each unit to have a particular frequency. You can say when the frequency is equal to my fixed frequency, skip to the next. So you scan, when you scan the spectrum and the frequency, when the frequency is equal to my frequency, then you can say frequency is equal to is equal, so you can assign it another value. You can say frequency is equal to my frequency plus 0.2, something like that. So it will skip, instead of giving you returning your frequency as the new frequency, it will return the next frequency. And so you can do this for when you're scanning up, and also when you're scanning down, you do the same. You do similar thing. I want to copy and paste, but I'm writing with pen. So when frequency becomes my frequency, when you're scanning down, then you now say the frequency is equal to you assign to the frequency um, my frequency minus 0.2. So we'll skip your frequency to the next lower frequency. So that's how you can do that. So when you're scanning up or when you're scanning down, when you get to your frequency, skip that. You don't want to waste time transmitting on that frequency for any reason. Why? Because it is your frequency. You don't want to transmit to yourself. So you can write the code that way, and then you just have to assign my frequency for everyone. So when you write the code, you can say my frequency, right? So if, sorry, I think I assigned this wrong. So you can say here if, right? If frequency is equal to my frequency, then you have just one equals here. Yeah, all right. You have to write it properly. So here also if frequency, so double equals this. That's when you're comparing, then you assign it. All right. So double equals is for comparison, and then single equal sign is for assignment. So you assign that frequency to to drop by 0.2 megahertz, which is 200 kilohertz, and then it goes. You can assign 0.1, and it just drops by 100 kilohertz. So that's how you build the system. So now let's test what we built. We made some modifications to the general rule, and that modification is because we built this system on separate uh, units. So as you can see right here, we have the software defined radio receiver, and right here also we have the software defined radio transmitter. Right, you saw this from last week, and that's the, let's get everything in view. All right, so these are the switches we used to tune up or down, and on the receiver as well you have similar one for tuning up or down. Let's see if we can get closer. All right, and get it a little bit closer. All right, so these are Arduino Uno. Right now, this is not an 80 tiny. The software-defined receiver is an 80 tiny. Now, to test this, we're going to use our YouTube channel, our YouTube video from our favorite musician. Let's see. I'm going to find a video to play, and I want to avoid um, copyright strikes, so I'm going to use my favorite musician of all time. And so let's play. So, all right. So we plugged in the software-defined transmitter, and you can receive that in this. I'm going to fire up the volume. As you can hear from the speaker, let's amplify it a little bit. Just acoustic amplification. All right, so I'm going to show you something on the screen right here. Um, so when we program this transmitter, I'll show you the basic code we use here. Thanks to my friend Rob from MIT. I'm using his library for some of this video. Also use some from um, Alec House. But let's see. Right here on the screen is the code we're using for this. And let me just show you quickly what has happened. So we've set up the fundamental frequency to be 92.1 megahertz. So that's where we have to tune to our radio receiver to be able to receive this transmit signal, right? And when I load this code, when I say upload code, the transmitter will start from right there, and then I can change the transmit frequency by pressing on the channel up or down, and you will see on the serial monitor as the frequency is changing. So let me reset the serial monitor to 0. Let me clear the serial monitor, and then I'm going to reset my transmitter by pressing the reset button, and you can see it starts from 92.1 megahertz. If I change the frequency by pressing the yellow button, it goes to 91.9 megahertz. So my radio has to be on that frequency right now. My radio has to be on that frequency to receive the signal. So if I'm talking to a guy who's on 91.9, this is the time he will receive. So I'm going to show you from a different, maybe from our, let's do it from our software defined radio as well. So we've tuned our software defined radio to the same 91.9. So I'm gonna change again and see. So we're 91.7 right now. So we're gonna go down on our receiver also to the same frequency. As you can see, so I'm gonna go down again. 91.5, 91.7. So right now we're scanning to 91.92.5, 92.5. So we started from 92.1. Now we're at 92.5. So let's scan up on the receiver. Right, so we've arrived at the same frequency. Alright. So the fact that we're receiving the transmit signal on this place, that means the radio and the transmitter are resonating. So you've seen the scanning process here. So let me go back and show you the video so you can see how I'm tuning it. Alright. So again, you go to the switches on your radio and then you can press up or down. Alright, so here when I change the transmitter, I also change the receiver. So if I press to go to one channel down, then I can also find the same channel. Alright, I gotta make sure the frequency I am on. Alright, the transmitter is still scanning, so I gotta stop the scan. Alright, the transmitter has stopped at 94.9. I'm gonna show you what happened right there. So if you look at the serial monitor, I've stopped at 94.9. 94.9 on the transmitter. So let me go back in my receiver and scan to that frequency. Now I don't have a monitor for my receiver scanner, so I just gotta scan until I get to that frequency. Alright. So that means right now we're on the same frequency. This is 90, 91.94.9. So that's really how you tune this. So we are back to the same. So we're in sync. The transmitter and the receiver are in sync. Right now, there's a lag on my transmitter and on my broadcast setup. So I'm gonna cut it short right here. But if you have any question, let us know. We've built a transmitter. So we've built a transmitter and a receiver, and both of them are software defined. We use these soft buttons to tune the channels, both the transmitter and the receiver. When you have it in a unit, you have built yourself a walkie-talkie. So in the next episode, we'll show how to add maybe a microphone to this, because right now we're playing from a YouTube video, but we can add microphone to the system. So I'll give you the circuit diagram how to add a microphone to it. You can use a single transistor amplifier, or you can just add the microphone directly. I'll show you the biasing of the microphone if you want to use a microphone there. But I think it's preferable to have a transistor amplifier, or you can also use an IC amplifier. I'll show you the three options in our next episode. I'll show you the circuit diagram. You can go ahead and build any of them, and if you have any issues, you let us know. And we can also go ahead and build one as a demo for you. Okay. So and then after that, we're gonna have another series. Maybe we'll consider what's going to go first, because we're probably going to do other radios, other transmitters based on this software defined radios, automatic scanning and all that. We've shown manual scanning. You process and it starts scanning. We can show different ways. You can have a simplistic way. If you just want your transmitter to be going to a particular receiver, you can just use the minimalistic way and broadcast to that station. You don't have to change it all the time. Again, if you're operating in a region where license is required to operate a radio transmitter, please make sure you have the license. And the good thing about this module is that it goes as low as 70 megahertz, so you can actually operate at a safe range. Likewise, the receiver that I am using here also can go as low as 70 or thereabouts. So you can build your walkie-talkie outside the range that will interfere with your neighbors or people around your area. All right, having said that, thank you for sticking around to the end. Please like, share, subscribe, comment, and until we come back your way with more content, stay enthused. Bye bye.